Jai Hind everybody. I am Professor Devendra Singh. We will take this module on machine design. The subject code is KME 602 and this is our first lecture in which we will discuss about the introduction to machine design. The outline of this lecture is first we will discuss the syllabus. Syllabus consists of 5 units. Then we will come to the various definitions related to the machine design. Then we will come to the design requirements of machine elements. Then we will discuss the design cycle given by Asimov. Then I will discuss the design procedure, and the final topic for this lecture is standards in design, the various standards used in the machine design office. So, as far as syllabus is concerned, the very first unit consists of the introduction to machine design, various concepts, basic concepts like the selection of materials, BIS designation of steels and other materials, then design against static and dynamic load. Then unit 2 will be involved with the design of riveted joints, welded joints and shaft and keys, where we will learn about the various concepts to design these elements. Then third unit will consist of the design of spur gears, helical gears, introduction to bevel and worm gears. So, these are the mechanical power drives. We will learn about the design philosophy and design steps in this. Then unit 4 is the design of sliding contact and rolling contact bearing. These are the basically the supporting elements which supports the load and reduce the friction in any mechanical system or any machine. Then unit 5 is the design of IC engine parts like piston, cylinder, gudgeon pin, and finally, we will discuss about the friction clutches, the analysis of friction clutch, their capacity, torque transmitting capacity, etc. The lecture we start with the very first definition of engineering. What is engineering? There are two terms. First is the engineering. So, what is engineering? And then the design. So, engineering is can be defined in a very in a single line, that is the applied science to bring comfort for the human beings, and design is nothing. This is the this is the solution we make for a problem faced by the human beings. So, this is engineering design. In fact, when we define the engineering design, it is the solution or the plan created to convert the available resources optimally into the devices, processes, systems, etc., to solve the problems faced by the human being. And if we want to define it precisely, then engineering design is an iterative decision making process. This is iterative decision making activity to create a plans to convert the available resources, man, machine, materials, preferably into systems, process or devices to perform the desired function and to meet the human needs. This is engineering design. So, iterative nature of the design gives the way or gives the opportunity to make the solution optimal. Or then we come to the next definition, that is mechanical engineering design. If the output of the engineering design is mechanical in nature, then this is called the mechanical engineering design, mechanical output. Then this is called the mechanical engineering design, and this can be defined very precisely. It is an iterative decision making activity to describe. There is a description required, describe a machine or mechanical system to perform a specific function, with maximum economy and efficiency using scientific principles and information, technical information, and the imagination of the designer. Some problem may be arised, for example, to maintain the temperature and humidity in a room. So, this is a problem. Then air conditioner has been designed, and it should be economy. Now, we are looking the 5-star and 3-star for the economy. Then next step is the machine design. This is the part of the mechanical design in which we design the various elements of the machine. So, this is again we can define it is an iterative decision making activity to create a plan to make a right combination of correctly proportioned moving and stationary components to construct in a way to join so as to enable the liberation, transformation and utilization of energy for the need of human beings. This is machine design. This is machine design. So, if we design a power drive like gear drives to transform or transmit the power from one shaft to another shaft, this is under the machine design. Then various types of the design we can classify as this is empirical design. Empirical design is the design which is based on the experience, a long span of time someone observe uh, the activity and performance of particular system, and something addition or something innovation may be added to perform to improve its performance, that is come into the empirical design. Bullock carts, plow, all these and even the bicycle, these are under the category of the empirical design. Then the rational design, if a design is supported by mathematical analysis using the strength of material background and optimal optimization etcetera, etcetera, that is called the rational design. Third category of the design is the empirical and rational design. If we opt some dimension in a machine element and these dimensions we check by using the concept of strength of material, means we provide some mathematical support or mathematical decision we take to make it successful, then this is called empirical and rational design, decision based on mathematical logic. Then the design by innovation, like we have devised so many ways to make our design fast and competitive, like we are using the CAD and other softwares in the design field, that is called the design by innovation. If something we are designing using some advanced tools, then this is called the design by innovation. And next is the inventive or new design. This is the design which is a start or which have have never ever tried earlier. This is just a new design. It is started with a sketch idea. For example, some seeds are there which are fertile and non fertile. So, how will you segregate? You may have an idea to use some water, you dip the seeds in the water, the non fertile are lighter, so they will float. We may have some blowing the air over the fertile, and this fertile seeds are having the higher weight, so they will not fly, and the non fertile seeds will fly. And on the basis of this concept, we can invent some new machine. So, that will be a new or a new design or the inventive design. So, these are the basic definitions related to the design. There are these are some few which I wanted to point out here. There are a number of definitions available in the field of the design. Then the design requirement of machine element. So, whatever you design, always the design is having a value if purchasing power is there. So, whatever you design, it should be cost effective. This is the first requirement. So, we need to select the proper material for that, proper analysis and proper decisions we need to take to make our design cost effective. Next, whatever we design, it should be safe. If someone is using your design component, design system, it should not harm for him. So, it must be safe, it must be safe. Then strength point of view, it must have sufficient strength to take the designed load, whether this is fluid load, this is thermal load, or the or this is a physical load. So, the strength should be sufficient in the material to hold or to resist, to provide the safety against the applied load in the application. Then the rigidity, for example, in the shaft, we consider the two types of the rigidity, the torsional and lateral. Torsional and lateral. So, it should not deflect, it should not deflect. It is the example, particularly example I have taken for the shaft. So, it should not distort, it should not twist more than the permissible limit, and it should not deflect in lateral direction beyond the permissible limit. If it happens, it will create non-efficient working, and it will create the higher vibration. It may affect the whole system, and if it is not having the sufficient rigidity, it may cause the eventually into the failure. Next is the wear resistance. There are a number of elements in the mechanical engineering. They are subjected to the relative motion. Whenever two components having the relative motion to each other and subjected to the force, then the friction is there and the wear may take place, and if wear takes place, then the performance may affect it adversely. So, the materials selected for the particular application must have the sufficient wear resistance. Then the light in weight and compact in size. If you design something, it will be popular if it is light and transportable. Then manufacturability, material you should select for the machine that must have the capability to apply the manufacturing processes whichever is required to convert the raw material into the final shape. Then next is the conformance to the standards. It is always recommended that we should use the sizes, materials, etc., even the testing methods as per the standards to attain the required safety, reliability, and uniformity in strength. Then the reliability, exactly reliability. If we purchase something, it should be reliable. If you purchase a bulb, it should work at your home, then the reliability is there. So, whatever you design, it should be reliable. Okay, what is its expected service life? For expected service life, it should work efficiently, and it up to the expected efficiency, and it should comply the recommended maintainability or recommended maintenance. Then maintainability, whatever you design, it should be easy to maintain. If it is maintainable, then it will be popular and your design will be successful. And these are the basic design requirements of machine elements, and in addition to this, there will be a number of requirements which will be given by the user to the designer, which should be included in addition to this for final or real time design. Then the design cycle. This is given by the Asimov. So, first the design starts with the recognition of need. So, as far as recognition of need, it should not be a vague need. So, designers should be capable enough to find or to decide this is a real need for finding a solution of it. Then, if recognition need has been tested and it is find that it is real need to be solved, then we define, the designer defines the problem. In defining a problem, it is the input and output basically will be finalized and defined by the designer. If definition is not possible after analysis, then the designer has to rethink about the recognition of need once again, whether this is really existing need or this is a real need or the vague need. If it is there, definition of problem is verified. Yes, we can decide the input and output parameters. Then we move to the next cycle or next step, that is synthesis, to think about the new or the available mechanism which can satisfy the need. So, this is the synthesis. If available or new are there, then we will move to the next. If it is not there, then we will go back to the definition, whether definition is correct or not, input and output parameters are okay or not. Then if it is there okay, then we will think about recognition of need again. This shows this is iterative in nature, as we have discussed in the very first slide. Then after synthesis, if synthesis is available, mechanism we have selected for the solution of the need, then we will move to the analysis and optimization. We find the dimensions using the strength of material and other knowledge of the designer as per the system or process required to design, and then optimization techniques will be applicable. We will be applied. If during analysis it fails, we will back to the synthesis, whether we have selected the proper mechanism or not. Then if mechanism is okay, then we will go back to the definition of problem. If definition of problem we do not find any problem, then we will think again about the recognition of need. If everything is okay and analysis and optimization is correct, then after finding the optimal solution, we will go to the evaluation. We will apply the testing condition on this optimized solution of the design, and after evaluation, if we find this is going to fail, we will move backward at every step, and once this evaluation is successful, then we will move to the presentation. Presentation is the design will be presented in front of a of an authority which will approve our design. This is a complete design cycle given by the Asimov. Now, the design procedure. Design procedure, as design cycle starts from the recognition of need. Design procedure also start with recognition of need. After recognition of need, we have a specification of problem, input and output we have decided. If after decision of input and problem, input and output, the conceptual design we have prepared what is the mechanism. Then after that, we move to the next engineering analysis, and engineering analysis will involve several steps. First is the model formulation. This is mathematical formation, and after mathematical formation, we will perform the computation, and after computation, we will evaluate all these solutions of after computation, and these three steps together are called the feasibility studies. After evaluation, we will get some useful solutions, and useful solutions then move to the optimal solution. Out of these useful solutions, we will find some optimal best possible feasible solution we will get in optimization, and after optimization whatever design a single solution we are available, that is called the preliminary design. This is called the preliminary design, and after preliminary design we will test it for the design condition, whether it is successful or not. If it is successful in design, then we will prepare a detailed design in which we will prepare various sheets for the production part drawing, various drawings we will made in the detailed design, and after detailed design we provide a presentation in front of the authority which will approve this design and permit to the production level. Then after presentation, if it is approved, then we will move to the production system or production level, and engineering analysis, detailed design and presentation, these three steps together are called the design and planning phase. This is called the design and planning phase. Then after presentation, production will start after approval, and after production distribution is required. Once distribution is there, then consumption is there, consumption and use, and after consumption and use, the product will be retired. So, in this way, this is complete design procedure. Recognition starts from recognition of need to the retirement of the product, and from the engineering analysis, and this last production, distribution, consumption and use and retirement of the product, this is called the production and consumption phase. And now the chronological vertical structure, vertical construction from engineering analysis to retirement, these stages together are called morphology of design. So, this is our design procedure. Now, the standards in design. When we design something, we should follow some set of norms to get the uniformity in efficiency and specified quality. So, some norms have to be formed. So, standard is nothing. This is a set of specification for materials, parts, process, testing methods, etc., intended to achieve uniformity, efficiency and specified quality for that product. And in standards, as far as standards are concerned, there are number of standards we use in machine design office. First of all, few standards have been listed here, which are popular one. First one is standards for materials. So, there are standards from which we can get the materials for a particular application. Say cast iron for certain bull gear, for example, we can have the cast iron. For flanges of rigid flange coupling, we can use cast iron or any other component you can think of, for which you will get the materials, standard materials for the application. Then standards for shapes and dimensions. What should be the shape and what should be the dimension of any component. I can give an example. Suppose for unfired pressure vessels, if you are designing unfired pressure vessels and manhole you are designing, what shape of the manhole you should recommend, what dimension of manhole you should use and what kind of the reinforcement and what amount of reinforcement you should give, that is given as standards for shapes and dimensions, and even you will get this in the standards for unfired pressure vessels. Standards for fits, tolerances and surface finish of components, whatever you design, what types of fits should be given. For example, if you fit some gear, so on a shaft, whether it should be fit having the interference fit or all the transition fit or clearance fit. So, it should be there. Then standards for testing products, what kind of the test you perform for the products, for a particular product. ASTM is one standard for testing methods for the products. A standard for engineering drawing and components. So, 14 the IS 14,000 is there, for example. A standards for packing, how should you pack the design and product designed and final product to transport from one place to another place. These are the few standards I have mentioned here used in the mechanical engineering design office. Then types of standards, primarily there are three types of the standards in use. One is the international standards. So, these are the norms which are useful or which are accepted throughout the globe. So, International Organization of Standardization is the organization which set the norms which are applicable throughout the globe. Next is the national standard. So, there are the national standards which are only applicable for a particular nation, and for example, BIS is the Bureau of Indian Standards for India, then this is for Germany, and AISI, the American Iron and Steel Institute for USA. These are the national standards, and the company standards. Some companies forms their norms for their products which are applicable in this in a particular company and its sister concerns or sister companies. So, this is for today's lecture, and we will continue with the standards and its applications in the next lecture. So, thank you all.